Hi everyone, welcome back for another video. In this video, I will be deriving the series expansion of 1 plus x to the p. This is also the binomial expansion. So starting off with our general form of the series expansion, we have f of x equals f of 0 plus f prime of 0 times x plus f double prime of 0, x squared plus f triple prime of 0, x cubed plus da da da. So I like to think about each of the derivatives evaluated 0, it's just some coefficient. So some a sub 0 for the original function evaluated 0, a sub 1 for the first derivative evaluated 0, a sub 2 for the second derivative evaluated at 0, and a sub 3 for the third derivative evaluated 0, and so on. So we're going to let our function f of x be 1 plus x to the p. And with that, we can determine the coefficients for its series expansion. So, plugging in that function as our f of x, to figure out the first term, we'll let x be 0. So with that, we have 1 to the p. And 1 to any power is just 1. So we know that our first term is a sub 0 equals 1. Taking the derivative of both sides will let us evaluate what the a sub 1 term is. Doing so, a derivative on the left gives us p times the quantity 1 plus x to the p minus 1. Again, we're going to substitute 0 in for x. And that we have 1 to the p minus 1, which 1, any number is just 1, times p. So our a sub 1 term is equal to p. If we do this a second time, getting the derivative of both the left and right, we have p times p minus 1 times the quantity 1 plus x to the p minus 2. And we're going to set x equals to 0 again, evaluate it to determine what our a sub 2 term equals, and we get p times p minus 1 divided by 2 factorial, because the 1 plus x to the p minus 2 part just evaluates to 1. And I put 2 factorial in because 2 times 1 is also 2 factorial, even though anything multiplied by 1 is that number. This is going to come up more in the higher order terms. So if we do it another time, we can see that this is the case. We have 3 times 2 times 1, which is 3 factorial, times a sub 3 plus da da da. Evaluating it for x equals 0, we have a sub 3 equals p times p minus 1 times quantity p minus 2 divided by 3 factorial. And if we plug in each of these coefficients, we have the expansion for 1 plus x to the p is equal to 1 plus px plus p times quantity p minus 1 times x squared, all of that divided by 2 factorial. And then the next term, p times p minus 1 times p minus 2 times x cubed divided by 3 factorial, and so on as the pattern continues to grow. Thank you, and I will see you in my next video of deriving the power rule. And with that, it's really important to know this series when we want to derive the power rule. Thank you.